If you recall, we've already constructed truth tables for 3 of the 5 connectives that we'll be using. We sort of stopped and did some problems with the 3 connective truth tables that we did, but I want to pick up now and finish them. Remember, we've done the truth table now for the negation, for and for or. And I mentioned earlier we'll be doing 5, so let's go ahead and finish the last 2 of our connectives. First of all, let's do if then. As usual, we'll set up our truth table with 4 rows because there's a P and a Q, and seed them with the possible combinations of true and false. True, 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 false, false, true, and false, false. That's old hat by now. And I'll do the same thing that I did before in terms of deciding the truth value of these things, and that is just make up a simple sentence and decide if that's true or false. Nothing very formal, just common sense. So I'll make up a sentence for the implication, if then, where both pieces are true. So for instance, I might say, if it rains, then I will take my umbrella. Now, I've got to talk about the truth values here. Let's suppose that it really did rain, and I really did take my umbrella. If I said, if it rains, then I will take my umbrella, and it did rain, and I took my umbrella, the if it rained parts, or the it rained parts, would be true, and the I take my umbrella part would be true. And so the question is the compound sentence true? It did rain, I did take my umbrella, and I said, if it rains, then I will take my umbrella. I think everyone would agree that that would be a true statement. So the true combination would be true. Let's redo it again. I'm actually going to use the same sentence, but this time something different occurred. It did rain, but I did not take my umbrella. If that's the case, then it rains part is still true, but the I will take my umbrella part is false. So now I have a statement of the form true implies false. I said if it rains, then I will take my umbrella. It did rain, I did not take my umbrella. Is that true? Of course not. So the true implies false combination is false. Now, let's switch it. Let's take false implies true. I'll use the same sentence, but this time it did not rain, but I did take my umbrella. So the it rained parts is false. The I will take my umbrella is true. So now I'm looking at false implies true. It says, I said if it rains, then I will take my umbrella. It did not rain, I took my umbrella. Is that a true statement? The compound statement that I made. If it rains, then I will take my umbrella. It did not rain, but I did take my umbrella. Now think about that a minute. That statement says what I'll do if it rains, but it did not rain. I did not say what I'd do if it did not rain. So think about that a minute. I only said what I'd do if it did rain. So if it doesn't rain, think of it this way. There's no way that I could be saying something's false, because I only said what I would do if it rained. So that would still be a true statement. I did not say something that was untrue, because in fact it did not rain. And if you look at the false-false combination, the same logic follows here. I'll say the same sentence, if it rains then I'll take my umbrella. It did not rain, I did not take my umbrella. But the logic follows exactly the same as the previous one. I only said what I'd do if it does rain. So the fact that it did not rain means that there's no way that I could have said something that's not true, because I only said what I'd do if it rains. So that statement is also true. So think about the implication and how you're going to remember that. And probably you want to focus in on the fact that it's only false in one case. That's our fourth truth table for the implication. And remember, I'm always looking for a way to remember the truth tables, and the way I'll do it here is to focus in on the only case where it's false, and I will say it's only false in this one case when P is true and F is false. That's not a nice catchy way of remembering it, but it still works. It's only false in that one case. That's how I'll remember it. Let's do an example of that before we go on and get our fifth connective. Suppose I ask you to construct a truth table for the statement P or Q implies P and Q. We'll start out as we always do. We'll list our 4 rows with all the seeding, true, 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 false, false, true, and false, false, and then we'll figure it out. Now, in the past, I've worked in a single column because I have the technology, and when I want to replace a false or false with false, I can just do that on the same column. It's not so easy for you if you're working on paper, so I'm going to do it slightly differently this time, and in fact, I'm going to do it in pieces. Just an alternate way of thinking about it. You can do these problems any way that makes sense to you, as long as you follow the correct rules. But I want to show you a little variation on what I've been doing in the past. So what I will do here is notice that that statement itself is made up of that compound statement with an implication is itself made up of compound statements. So it might make sense to take each of those compound statements within the bigger compound statement and work with it separately and find the truth values, and then put it all back together at the end. So this is different than what I was doing in the previous section. It works either way in both cases, but as the problems get more complex, it makes a little more sense to break a complex statement that is made up of other complex statements into pieces. So let's do it that way and see what you think. If you're going to do that, then each piece gets its own column. So this P or Q over here gets its own column. And this P and Q here gets its own column. And I'll work with each piece separately and then put it all together at the end. So in that vein, let's just work with this piece right here, which means I just work with that column that I've added. So I added a column for each piece. Now that's just an OR. That's P or Q. And I know what the truth values are, but let's go through them more carefully. I've already got it seeded with all the possibilities, true, 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 false, false, true, and false, false. But now I put in, everywhere there's a P on the first row, I put in true. And everywhere there's a Q, I put in true. For the second row, everywhere there's a P, I put in a true. And for the Q, I put in false. On the third row, I reverse it. P is false and Q is true. And on the fourth row, they're both false. And I remember for ORs, my little memory phrase is, it's only false if they're both false. Well, there's only one place where they're both false. So that's false. Everywhere else will be true. So I've completed this. And what you'll notice is, what I've done is I've gotten the truth values for that compound statement on the left. So what I want to do is now move to the second piece, the right compound statement. So I'm taking this thing in pieces. So now I want to work with P and Q. I'll seed them again. Again, both P and Q are true. P is true, Q is false. P is false, Q is true, and then both are false. The way I remember an AND is only true if they're both true. So looking at this, the only place where they will both be true is true and true in the first position. So that becomes true. The others are then obviously false. So now that I've done each piece of the more complex implication, I want to put things where they belong. So the truth values that I work for in that third column get moved over to where they belong underneath the or in the more complex statement. And similarly, the and column values get moved over under the and in the more complex statement. So you get that. And now I'm ready to tackle the implication. So now this column looks much simpler. I only have to tackle the implication itself. Well, how do I do that? You use the truth table that we just developed for implication. And if you recall properly, my little memory phrase, although it wasn't very catchy, is that it's only false if P is true and Q is false. There's only one case where the implication is false, and that is if P is true and Q is false. Not catchy, but that's the way I remember it. If you look above, where is P true and Q false? Well, P is a generic term for the part on the left, and Q is the generic term for what's on the right. So they don't literally have to be P's and Q's. The P stands for the piece on the left, and Q stands for the piece on the right. So where is the piece on the left true and the piece on the right false? Well, there's a place, and there's a place. So those are the only positions in that last column where the implication is false. So I'll go ahead and put those in, or at least note them. That means the other two are true. So I put falses there and trues in the other two positions. Now again, in the interest of doing it the way you would do it on paper, I want to create a new column for that, because you're not working with this technology when you're sitting down and working the problem. So what you would actually do is just create another column and push those values over there and write them that way. So even though I worked with my technology to make this thing efficient earlier to show you how to do these things, when you're actually working them on paper, you're more likely to do it this way. Also keep in mind, even if you don't rewrite it, those intermediate columns are just your scratch work. They're just intermediate results. They don't mean anything in the end. So you might not actually get rid of them, but just to help you think about this, those intermediate columns, once you've used them, are irrelevant. What you're really interested in focusing on is the result at the end after you've completely simplified it. So that would be the truth table for that original statement. Simple enough. You have to be careful, have to be organized, but the process is fairly straightforward. We've done 4 of the 5 connectives, so let's knock off the last one. The last connective is the biconditional, or what we say sometimes as the if and only if. We indicate that with a double-sided arrow. Now, in reality, the biconditional is actually equivalent to 2 implications that are ANDed together. So the biconditional, this P if and only if Q, is really equivalent to P implies Q ANDed with Q implies P. So we could do the truth table for the biconditional by putting this in the last column and doing just what we did in the earlier problem, going step by step and putting in true, 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 false, false, true, false, false, and then simplifying. So we could work it out. And in fact, it's probably a good idea, really, if you went off at some point and did it for yourself just to convince yourself that it's right. But here, we've done enough of that, I think, for the time being, and we're going to do more. So I'm just going to produce the final results here. Just cut straight to the chase. And here's what happens. When you simplify that out, what you'll get in order is true, false, false, true. And you're always looking for a pattern, so it's easy to remember what these things are. And the pattern here for the biconditional is simple enough. If the P's and Q's match each other, it comes out true. In other words, if P is true and Q is true, they match, then the result is true. If P is false and Q is false, in other words, they match, then the biconditional is true. But if P and Q differ, one is true and one is false, then the biconditional is false. So that's going to be the way we remember the biconditional. We're always looking for these little memory phrases. And I would say that you remember the biconditional by saying it's only true if P and Q match. And while I've got it here, I want to say again what I said earlier. When I say P and Q match, or in any of those cases, any of those memory techniques, P can stand for a more complicated expression, so can Q. For instance, in the last problem I worked, what I really meant was the left-hand side, whatever was over there, when I worked the one with the implication, that was like the P, and whatever was on the right side of the arrow was like the Q. It doesn't actually have to be P and Q. You're just thinking in terms of P and Q because that's the most common way to write it. That's all 5 are connectives. Let's do an example with the biconditional. It says to construct a true statement for this statement. And we proceed exactly as we did with the implication, except we're using the biconditional truth table. So we seed our table, and we'll break it down into pieces again. We notice that there's a compound statement on the left of the double-sided arrow and on the right. So we'll break it into pieces and make a column for each piece, just exactly like we did before. And once you get started, it all flows the same. Each piece has its own column, and we'll start off with the P or Q column. I'll go through this a little more rapid than before because it's so similar to what we just did. We put in the trues and falses based on which row we're on. And then remember that for an OR, it's only false if they're both false. So this will be the only false. Put it in. The rest of them must be true. Then we move to the next column. Put in the values for each row, both true, true, false, false, truth, and false, false. And then remember for an AND, it's only true if they're both true. Well, there's only one place that happens, so that's the only true. The rest must be false. Now you want to move things over. This piece belongs under the OR in the last column, so move that over. The AND piece belongs under the AND part of the expression or the statement that we're trying to construct this truth table for, so you move that over. Now you're simply left with the last column being a biconditional, and then you bring up your memory phrase. Your memory phrase is it's only true if P and Q match. And again, remember, P and Q are just generic names. What I'm really saying is it's only true if the left-hand side matches the right-hand side. So look, the left-hand side matches the right-hand side here, so that will be true. And the left-hand part matches the right-hand part at the bottom, so that will be true. And the other two, then obviously, will be false. Like I said, if you're writing this down, what you really want to do is just create a new column and move those truth values over. And as before, whether you actually do this or not, you need to keep in mind that the intermediate columns are just that. They're just scratch work. What really matters is what's in the last column. And now you have the truth table for that logical statement with the biconditional. It takes a lot of practice. You can't just watch someone else do it. You have to get your hands dirty and go in and practice. And that's what your homework is for. So practice away.